Okay.
I wasn't expecting to speak at PyCon, but here I am. Yeah, so thanks David and Adam for creating the opportunity. So this is going to be a bit of a norm core talk. There's not going to be anything really deep technically wise in here, but I hope it'll still be interesting to people here. Before I jump in, I'm just going to say just a couple words about who I am. So my name is Lachance. My pronouns are they, them. I'm a staff engineer at a company called Voltus, which I'll talk about in a minute. And I spend a lot of time working with Flask, in particular a large Flask application, which I'll be talking about in this presentation with reference to OpenAPI and APIFlask. So as the talk's title would imply, this is a presentation about OpenAPI and APIFlask and why I think these two things are great. But I think it's actually kind of my higher level meta purpose is to talk about how to adapt software to the needs of a larger organization as it grows. I really enjoyed Adam's presentation earlier today, talking about kind of how to build an application at an early stage when you have a relatively small number of developers. I think this might be sort of like what happens 8 years later sort of thing. But anyway, I hope you take away from this like some ideas about how to build things that others will find useful, and some things that you might be able to apply to your own organization or open source projects that you might like to build, even if you don't really, see reason to use APIFlask and OpenAPI. Okay, so just real quick, I don't want to turn this into a commercial, but I think to set the context, I do just want to talk a little bit about my company and kind of the history of why and how we wound up using Flask. So I guess the industry I'm in is called demand response. So Voltus essentially provides a platform that allows our customers, mostly commercial and industrial users of electricity, i.e. large users of electricity, to earn money by providing energy to the grid during periods of peak demand. This could mean turning on a generator or like discharging a battery, but like more often than not, it just means turning stuff off if you don't need it, or if you can live without using it for a little bit, or you can live with using less of it for a little brief period. So like a canonical example in a venue like this, which incidentally is a Voltus customer, I learned that while I was doing the prep talk for this, but I can talk about it because we made a press release about it, is that like they're signed up to participate in some programs. So during a really hot day in the summer, when the grid is like all maxed out, they might turn up the AC by a degree or two. Probably the people inside the building won't notice, but it could prevent a blackout or all sorts of other problems from occurring. So this is interesting to me for a couple of reasons. I guess the first reason is reliability. We all like having power when we need it, and we really notice it when we don't have it. But I guess the other side of it is, as we go through the energy transition, and we transition from using fossil fuels and to like more and more nuclear, the supply becomes more and more, I wouldn't say less reliable because it's still predictable how much you're going to have, but it's not, you just have as much sun as you're going to have on that day. You have as much wind as you're going to have on that day. So being able to influence the demand side is sort of a key part of making that work. So yeah, it's kind of motivating from that side of things for me. But yeah, this company is relatively young. Like demand response is pretty old, but like sort of commoditizing it in the way that we're doing right now is like a relatively new concept. But I guess it's not super young, right? So Voltus has been around since 2016. So I'll just talk briefly about like where we started. Oh, actually, before that, just a quick slide. This is how it works. So like this is like real-time energy of a particular customer. I can't even remember which one. You can see in the circle there, that green bar is like sort of a demand response event, and that represents where we'd like them to go. In this case, the customer curtailed, so you can see their instantaneous power usage just sort of fall and then go back up again after the event ended. So yeah, why Flask? Okay. Since I'm presenting here, it's probably not going to be a surprise that we use Flask pretty extensively. And And in fact, like basically from the company's inception, when the technology platform was started, Flask was used to model the domain and help facilitate the tasks I outlined in the previous slide. So I've only actually been at Voltus for a few years, so I kind of like asked the CTO for some context about like why he decided to use it. And I think I'll just read this line verbatim, but it's like probably going to be super familiar to everyone in this room, or at least anyone in this room who's like used Flask a fair bit, is that it says like, I knew I wanted to build a monolith because I'd be the only person maintaining it for the foreseeable future. I knew I wanted to use Python because I'd be doing time series processing and I was pretty comfortable with pandas. I'd mostly used Django at that point, but I didn't like how heavyweight it was. I liked that I could add complexity as needed instead of starting with it all at once, right? So in the beginning, you know, like there's this, I think, you know, the technology platform was just like a fairly minimal Flask application, like doing some key tasks to integrate with system operators and acting as an intermediary with customers. In the early days, like I think a lot of stuff was still done manually. So like it's not like this thing had to do everything, but the things it needed to do could all be done like just within a single Flask monolith. But that was like circa 2016. Here we are in 2024. Yeah, I mean, the company's just grown a lot, right? So that means that we're in more markets with more programs, many more customers than we had previously. All this stuff needs to be supported by a much larger team than was there existing previously. You know, started with one person. I think, I'm not sure of our exact count, but like it's within the 40 or 50 range, I think, that we're at this point. So yeah, like around the Flask monolith, we've certainly grown like a fleet of microservices to handle various tasks at every level of our problem domain. This here is like sort of a simplified diagram of that. So you still have Flask at the center, but there's like, you know, these scheduler and dispatch connectors that are like at the market edge. There's a public API, which sort of acts as its own service that like gets its information from the Flask monolith. You know, there's telemetry, performance and settlement services, and probably a million other things that I'm not picturing. To go through it all would take a very long time. But I guess sort of the core point is that like Flask is still at the center of this, right? So the core database model and business logic still lives in a service that we call VoltAPIFlask. In microservices, they make it tractable for a larger team to change small parts of the system. Like we're kind of at the point where like everybody working on this monolith at one time and deploying all the time, they'd be stepping on each other's toes, and like it would just require too much context and understanding. But that said, like even though we've kind of created this model where people can sort of like mostly work at the edges, understanding the core is actually still really important, right? Because like the core details about all of our customers and all the programs that we're in, they're still within that Flask monolith. I'm getting to APIFlask, I promise. But like what's kind of like the problem here? It's that like newer people, they might not need to touch the Flask monolith right away. Like certainly I didn't. I think it was like a few months into my tenure that like I actually started working with it a bit. And the issue is that like if you only touch something sometimes, you might not like really fully understand it, what its capabilities are, you know, where and when you might use it, when you might need to add stuff to it, you know, that sort of stuff. And like there's kind of like this knowledge gap that gets created that you really want to find some way of bridging, right? Like one sort of motivating thing I found out about was like when I was working on all this stuff is that like I think we have like 3 endpoints to get facility information that are more or less duplicates of each other, right? And it's not because people are stupid or anything like that. It's just because like if you're only working, you know, in one area of the system and like maybe you're only working in one area of the Flask monolith, you might not be aware of everything else that's going on. So it's like kind of at this scale that you really want to use technologies to help automatically document and like make your system comprehensible in a better way than like just telling people, oh yeah, just look at, you know, this 20,000 line Python application, you figure it out, right? That's not a really super satisfying answer. Much more tenable when you're small, less tenable as you get bigger. I can't even imagine like what it's like at I haven't worked at a company like, I don't know, Lyft or something, or Uber, which like handles like an order of magnitude more, but I'm sure it just becomes even more so that way as you grow. But this is where OpenAPI, I think, is really useful, right? I'd say like, this is a bit of a hot take, but like my feeling is that like OpenAPI's main utility is making a large code base like ours by providing built-in indexing and documentation of the API service. Like at heart, all you're doing with OpenAPI is you're saying, here's a JSON file with all the API methods in my application, and here's the inputs that they expect, and here's the return values that you expect. And there's like other things you can do with them, like generate client-side libraries and things like that. I mean, which is sometimes useful. I've sometimes been disappointed at what the client libraries look like, but like the core sort of documentation piece is like really where I think there's value. Because like all of a sudden, like if you use a system like Swagger, which I'll show in a moment, you can see sort of at a glance, everything that your application is capable of doing and experiment with it. I don't think OpenAPI is super new, but it's certainly become more widely adopted more recently. We'd been using it already at Voltus to document our other microservices, which have generally been written in either Go or Goa or Python and FastAPI. But I mean, Flask is still there and it's super important, right? And it didn't have OpenAPI support out of the box. At one point, I think people were considering an almost complete rewrite of the whole thing as a set of microservices or moving to another framework like FastAPI. I don't know, when I heard about that initially, I was suspicious, and the more I learned, the more I felt, no, this is like not a direction we should go down. Like it's way too much work. I mean, I guess I'm presenting here, so I'm a little biased, but like, I think Flask is good. Flask is fine. Like it doesn't, if you have a Flask code base that's working, I don't think you should rewrite it or replace it. Like just let it do the thing that it's and it's good at, and add a few things, right, where there's something missing. So that's kind of, that's after doing a bit of field research, like I felt, yeah, a Flask add-on is probably the way to go. And I think, I did a survey, I think of 10 or so, and I think out of them, like APIFlask really stood out to me for a few reasons. One, like super actively maintained by somebody who seemed like they knew what they were doing, Gray Lee. Two, it had really good documentation. You can go to apiflask.com and check it out. And three, I think this is kind of a more subtle point, but there was I saw immediately after experimenting with it that there's like an incremental migration path to using it. So I'll unpack that a little bit in the coming slides, but I think that's like a really important point. So how does it work? How do you got an existing Flask application, you saw a few examples if you were at the earlier presentations of what they look like. How would you add APIFlask support for it? Just to get started, like really you would just import like some subclasses that APIFlask defines over the Flask equivalents, and then just start using them, right? So like it's a bit of a crude diff, but like, and like it's a little bit more involved than that, but like mostly it's just about like just importing API Blueprint and APIFlask and then just using them where you would use the Flask equivalents. And you don't get everything from doing that, but you get some of the way, right? Like, so I think my initial pull request to use this stuff was actually like relatively small. Like like I said, a few more things than this, but not really all that much more. And then all of a sudden, if you use APIFlask's built-in support for Swagger, or you can write your own, I wound up having to write a bit of my own just for reasons I won't get into. You end up with this really nice browsable documentation, right? Like in our case, this is kind of just for developer access only. Like at least for the Flask application, it's not a public API, but like for internal developers, like this sort of stuff is gold, right? You can use the browser's built-in search feature to see what's theirs already. Provides a summary of comments that people have provided previously, like just super useful, right? Some limitations in that, like, if you just sort of use the naive approach I just mentioned, you won't be specifying the input or the outputs of any of these methods. So it's not like quite as comprehensible as it should be, but like with just like a little bit of work, you get like this really, really nice index. And you know, it works essentially just like the thing that you had before. But so that was like kind of really easy to convince people of. And like that, you know, something just as an individual contributor, I could more or less do myself and get adopted. The next step is a little bit more involved, right? So the next step is to, you know, add schemas for everything that these endpoints take as input, and then likewise do the same for output. So like internally, APIFlask just uses the Marshmallow serialization framework, pretty similar to Pydantic if you've used that. And yeah, it just provides like a set of classes that you can use, and then you can just define, you know, basically what your JSON API is doing, right? Like in this example, this is a Voltus-ish example where like the latter piece, utility accounts output, defines, you know, what we would expect the API to return. That is, you know, a dictionary with a single item with the misspelled utilities accounts. And then it's a list of the items above, which would just be a list of JSON dictionaries with the properties id, name, and address, right? And then yeah, you would just, to start using that schema, you would just add a decorator to all your Flask methods that are defined against an API blueprint. And then you just say what their output is, and it would start using them. And the same rough thing is true for input. The nice thing about doing an input schema is that you get validation for free. So like say you're using an input schema to expect post input, it would validate that the JSON that you're sending corresponds to the fields that were expected there and the value types are right. And if they're not, it'll give a very standard error without you having to do anything, which is pretty nice. Not a game changer because like there's existing libraries to do that, but it's, you know, it's nice to get something like that out of the box when you can. I'll come back to this caveat in a second, but yeah, I mean, the end result of doing that is, you know, you get detailed documentation of exactly what kind of response you can expect your method to return. And then you get this nice sort of like input field, which like itemizes each of the inputs and what you expect for each of those. I gave this presentation internally a couple of days ago, and people brought this up, so I kind of feel obligated to mention it. There is like one caveat with these schemas. Like often just the naive way of like writing JSON endpoints in Flask, you would often return output like that on the left, where you just have like a dictionary with the keys, you know, having some identifier and some sort of value. I have not been able to figure out how to express this type of thing with an APIFlask schema. I'm pretty sure it's not possible. You can see a discussion item on it in the APIFlask repository if you're curious on more, but I've kind of sort of come to the conclusion after too much research that it's probably just not going to work, and that what you should do is you should write new endpoints using the form on the right, where you have a dictionary with, you know, well-defined outputs at the top level, right? So like if it's emails with some sort of property, say that it's emails and show the property. I mean, it's more descriptive to the user anyway, but yeah, I don't know. I think migrating everything to our existing endpoints, which use the thing on the left to the ones on the right, that's a little bit of a work in progress. It's going to require a bit of versioning, a bit of a pain. I don't know, just a caveat that you should probably be aware of. It might not affect you. But yeah, obviously adding all these schemas it's an iterative process, right? And you know, generally you kind of need to get a scope of work and figure out what needs to be done. I think one of the interesting points about OpenAPI is that because you're kind of expressing your code in this easily parsable data structure, it's like super easy to like, export it as a CSV or a database table or whatever you might need, right? So like here's an example of like parsing out an API specification into a set of Python dictionaries, and then we just iterate through them, add them to like a list, and then we create a pandas data frame. And this was exactly like this. I've migrated a few of our blueprints, and the plan of attack always kind of looks like this, right? What are the endpoints that have a blank schema indicating that we haven't fully migrated them yet? Here's the list, generate tickets, do whatever you need to get people to migrate things over. I really like expressing code as data. It's really useful when you have a larger code base. Just getting closer to the end. One thing I'd like to talk about is one of the benefits, I think, of doing something like this is kind of like the second order effects. So like documentation is useful, but sometimes like getting people to write documentation is also useful in a sense, because like it forces them to interact with the code base and figure out what it does. It's especially useful to newer people. Like for a lot of people at my company, like this Flask migration was the first, like the tickets that they did for that was their first big interaction with the Flask code base. And like a lot of them came to me later saying, yeah, this made me a lot more comfortable with this. I'm now more comfortable adding new features. And like there was a few cases, especially with the dispatch team, where they added one or two things that were new to the Flask monolith where it made sense, where previously they would have just done it elsewhere in a way that made less sense. So it's like, I think sometimes these efforts can sort of be, I don't want to say they're worthwhile in themselves, but they can have sort of side follow-on benefits. So that's something to consider. So last slide, takeaways. One, don't let anyone tell you it all needs to be rewritten. Flask is great. You can keep on using it. Even if you want something like OpenAPI, just find a good add-on. Second, I really love tools that allow incremental adoption with benefits along the way. If you're writing tools or libraries, think about that. It's worth thinking about. And then last, APIFlask is great. And thanks especially to the maintainer, Gray Lee, for such a great piece of software and for giving his blessing for me to talk about it today.